Okay, so proportional relationships and unit rate. This isn't anything new. This is stuff that we've looked at before. It's just kind of a review of how to read these graphs and how to plot them on the graph when you're given data. Remember, proportional starts at the origin. So 0, 0 is your first point, and it goes up from there. Basically, your change in y over change in x is the same. Okay, so it's still change in y over change in x. That's what we're looking at most of our years, change in y over change in x. And then your unit rate. So remember, unit is a singular word. So it's per 1 or x over 1. So on the first one, Myra walks a constant, so same rate of 8 miles every 2 hours. So 8 miles every 2 hours, y over x. Graph a line to show the relationship between the time in hours, t, and the distance in miles, d, that Myra walks. Okay, so I'm going to go ahead and start plotting some of those points. So she walks 8 miles every 2 hours. So first thing I want to do is look and see what my graph is going by. So my hours is going by 1. My distance is going by 3s, but there's these little lines here, so that's technically 1, 2, 3, 4, 5. So it's kind of going by 1s. So I'm going to make my first point on 8 miles every 2 hours. So I'm going to come up to 8 miles, which would be about here, every 2 hours. So I'm lining those two up. Does that make sense? To make your point. Okay, so if she goes 8 miles in 2 hours, then she would have to go how many in 4 hours? So 16, right? If we're just doubling it. So 16 miles, which is about 15, 16 right here, in 4 hours. So I'm going to connect those two and put a point right there. And then if she's going, we'll go backwards one. So if she's going 8 miles in 2 hours, how many miles is she going in 1 hour? So divide pretty much. 8 divided by 2, 4. So she's going 4 miles, which we are here and right here. And then if they wanted us to connect the dots, we could, or if you are better at drawing than me, you could do that actually. Oh my gosh, it's getting worse. Okay, so what is the unit rate in miles per hour? Remember, so unit rate's 1, and that's what we figured out last. So the unit rate, so the miles per 1 hour. So 8 miles in 2 hours, 4 miles in 1 hour. So 4. That's your unit rate, so per 1 hour. And what is the slope of the line graphed? Unit rate and slope are the same thing. It's your change in y over your change in x. Technically, I guess you could say 8 over 2, but then what does that reduce down to? 4 over 1, or 4. So those are the same things. Those mean the same things. How does the slope of the line compare to the unit rate? Like we just said, they're the same. It's the change in y over the change in x, which is most everything we do. Okay, Mr. Nguyen, maybe, buys a rope by the foot from the hardware store. The graph shows the relationship between the rope length and the cost. So we're comparing cost to the length. And it doesn't give me any points, so I'm going to have to make my own points. It says, write a statement that describes the unit rate for the rope Mr. Nguyen purchases. So my rope length in feet is going up by 1s. They just don't have them all filled in. And same thing for my cost. It's going up by 1s. It's just not all quite filled in. So I'm going to make my own points so I can better see what the unit rate is or the slope is. And remember, we want to make those points in the crosshairs. So about right there. And remember those crosshairs, it means in between where it crosses. So I'm going to make a point there. I don't want highlighter. I can make a point there. I can make a point there. And so now I've got enough information I can kind of figure out what the slope is, and then from there what the unit rate is. So my change in y, it goes from, I guess technically there's a point here. So my change in y is 1. And my change in x, my vertical change, is 2. And so just to double check that, I could check the next one up. So it goes from 1 to 2, so that change would be 1. And then it goes from 2 to 4, so that changes 2. So again, 1 to 2. So that's my slope. But if they wanted unit rate, then I would have to figure out, so it's 1 over 2, so that's $1 for 2 feet. So what's the price of 1 foot? Well, we can divide, and so it should be 50 cents or 0.5 for 1 foot. So write a statement that describes the unit rate for the rope. I'm going to say it's 50 cents per 1 foot. Number 3, the graph shows the relationship between the number of cups of peanut butter and the number of cups of sugar in Mrs. Meyer's peanut butter cookie recipe. So we're comparing sugar, because that's my y value, over peanut butter, because that's my x value. So based on the information in the graph, what is the unit rate? Remember, slope just reduced. For the cups of sugar per cups of peanut butter. So let's make some points. I think I can make a point, oh my gosh, right here. And maybe right here. And right there. Okay. And so it looks like my change in y, well, first of all, let's see how this y value is increasing. So I've got these 1s, but these little squares are representing something. So I'm guessing it's going by quarters. Right, so I start at 0.75. It goes from 0.75 to 1.5. So think about that difference, 1.5 minus 0.75 minus 0.75. And so that difference would be 0.75. So that's my change in y, and then my change in x. 1, 2, 3, 4. I know I go over 4 squares, but look at your graph. I just went from 1 to 2, so just 1, okay? So that's my change in x, so 2 minus 1. So 0.75 over 1, and since it's already over 1, that's my unit rate. So 0.75 over 1. So 0.75, or if you're talking about measuring, they usually use fractions. So 3/4 cup of sugar for every 1 cup of peanut butter. Okay, in the back, number 1, the graph shows the relationship between the time and distance a cyclist travels. Which of the following best describes the slope of the line? First of all, let me find the slope of the line before I even start looking at these. So slope of the line, so we're looking at miles over hours. And I'm going to put a point right here. So that's at 30 and 2. So 30 miles in 2 hours, which would reduce down to be 15 over 1. If you divide that. So 15 miles in 1 hour. So now that I know that, let's look at these answer choices. So the cyclist travels at a speed of 1.5 miles per hour. No, not even close. Not 1.5 miles. If he goes 30 miles in 2 hours, then how would you drop all the way down to that? Not possible. The cyclist travels at a speed of 15 miles per hour. Okay, maybe, because that's what I got up here, assuming my math is right. C, the cyclist travels at a speed of 8 miles per hour. Again, if you can go 30 miles in 2 hours, then you're just cutting that in half. So 8 miles would be way too short. And D, the cyclist travels at a speed of 20 miles per hour. No. Even if I looked at my graph, 20 miles is right here. And so that's a little bit higher than 1. So it's going to be B. Number 2, students organized a walkathon as a fundraiser. The graph shows the amount of money earned during the fundraiser. So which best describes the amount of money raised per mile? So again, let's find some points and see if we can't reduce that down to make our 1 unit rate. So I'm seeing not a lot of good spots. I see one here. Maybe I'm blind, but that's the first good point that I see. And that is at $700. And that's my Y value over my X, which is miles. And that is 4. Okay, so $700 for 4 miles. So let's go ahead and reduce that or divide it. So 700 divided by 4, I get 175. So 175 for 1 mile. And even just from that, you could go ahead and eliminate G because it's not 700 per mile, it was 700 for 4 miles. F, if it's 700 for 4 miles, then 900 per mile, especially even if you looked at the graph, 1 mile is down here. That's not anywhere close to the number 900. Okay, so then between 175 and 200, that's where the math comes in. 700 divided by 4, we got 175, so we know it's H. If you were just guessing though, if you were just trying to guess, 200 is pretty darn close to that line. Okay, but it doesn't quite cross that line. Oh, wait. Yeah, it doesn't crack. I'm sorry. 1 would be here. So it doesn't quite cross that line at 200. So it would have to be less than 200. If you had not done that math and you were just looking at the graph, the line does not quite meet 200. So 175. And the last one, number 3, a parking lot owner charges $9 per car for parking. Which line can be used to model the relationship between C, the number of cars in the lot, and D, the number of money collected. So D, that's our dollars, C, cars in the parking lot. So we want to look for one that's going to reduce down to 9 over 1. So let's look at A. So for 1 car in the parking lot, it's about at what might be 10. So I'm going to actually have to find a point on here and reduce it just to be safe. So I think this might be a point. Is that crazy? That might be a point. That actually looks like a pretty good point. So we'll see. 10 divided by, or 80 divided by 9 up here. And we get like 8.8. And that one looks like it's at 10 over 1. We'll put a star because that graph's kind of hard to read. So let's look at B. So $9 for 1 car is what we want to find. And we've got a point. I think there's a point here. I think there's a point here. I think there's a point here. And so that would be 10 over 2, which would reduce down to be 5. So that would mean $5 for 1 car. We're looking for 9, however. So let's get rid of B. Then on C, holy cow. On C, it's saying that $2, $4, $6, $8, $10, and 20 cars, 40 cars, 60 cars, 80 cars, 100 cars. Okay, no. We need those cars to be 1. I need 1 car to be down there. So they have their money and they have their cars flipped. So I'm not even going to keep looking at that graph because it's already set up wrong. And same thing on D. It's set up wrong. So by process of elimination, our answer should be A, even though that graph was sort of hard to read. But that's the closest one to being the $9 for one car. So we're going to go with A because the rest of them don't make any sense.